Thank you, Mr. Don. Good afternoon to all of you. My name is Elizabeth George. I recently completed data analysis pathway with CodeU. I am a stay-at-home caregiver for my son. I hope he is listening to music. I have a master's degree in computer applications. Despite embarking on a professional journey as a system analyst 20 years ago, I always had a passion for learning and exploring new opportunities. And CodeU has played a significant role in sparking that passion and instilling confidence in my abilities. And my goal is return to the workforce. And today I'm grateful for the opportunity to present my project, Climate Change Data Analysis. Now, the question is why this as a project? Firstly, because of my profound passion for nature. Secondly, because of the increasing evidence of climate change and its adverse impact on environmental resources. Thirdly, this project offers valuable insights for scientific researchers to understand the factors and patterns of climate change. Finally, this project supports policymakers in understanding the socio-economic impacts of climate change. Next, what are the key elements of the project? First module, greenhouse gas emission analysis compares emissions across sectors, gases, and countries. Next module, historical temperature data analysis compares temperatures across hemispheres, latitude bands, and land and ocean. Let's explore the first module. The data has been taken from the United Nations Framework Convention on Climate Change website, and I use the read Excel function to read the data from the Excel files and generate the data frames. Additionally, I cleaned and processed the data using Python's Pandas library and SQLite. Furthermore, I utilized NumPy, Pandas, Matplotlib, CPON, and Plotly libraries to conduct different data analysis. Given our time constraints, and let's examine some coding visualizations. This example calculates the emission percentages using Python's ilog function to access the data frames. Let's examine the outcome of the code. This is a bar chart explaining the comparison of emission between 1991 and 2021. X-axis shows agriculture subsectors, while y-axis displays the emission percentages. Clearly, fermentation and agriculture soils are two major factors with the high emission rates, and it can impact the farmers and regular people to make conformed decisions. Let's move to the next chart. That's a bar chart explaining the comparison of emissions by different types of gases. Here, x-axis shows different types of gases, and it is clear that carbon dioxide is the main greenhouse gas with the high emission rates. As we all know, as the carbon dioxide increases, the temperature increases too. And this is a grouped horizontal bar chart explaining the comparison of emissions across different countries. And in this graph, United States of America has the highest emission rate in 2021. And I handled a major challenge in the project by another process. And to resolve this, I used a retry mechanism. I set the maximum number of retries to 5 with the delay of 1 second between retries. And inside a for loop, I had execute query function and which connects to the SQL database and writes the data frame content to a database file. Let's move on to the next module. The data has been taken from Goddard Institute for Space Studies website, and I use the read CSV function to read the data from the CSV files and generate the data frames. And stats models is the key library I utilized in this module. Building on that point, let's explore the graph. It represents the temperatures across different hemispheres. And x-axis represents the years and y-axis represents temperatures. And it is evident that there is a gradual increase in the temperature from 1991 to 2021. And in this code, I have used lowest function of the stat model library for calculating the annual temperature mean and go.scatter function for creating the traces for the graph. Turning our attention to correlation coefficient analysis. And this graph shows the correlation between the emission percentages in 1991 and 2021, and x-axis representing 1991 and y-axis representing 2021. And the coefficient of 0.99 indicates a strong positive correlation, meaning that as the emission percentage in 1991 increases, so does the percentage in 2021. And I use the Seaborn library for visualization. Let's shift to a Tableau visualization of temperature and population analysis across countries. And this results indicate that as the population increases, so does the temperature. To conclude, let's recap the key points of the project. The analysis of greenhouse gas emissions and the historical data offers variable insights into climate dynamics and trends, enhancing the understanding of emission patterns and targeted intervention areas. These findings emphasize the need for ongoing policy monitoring and sustainable environmental care for the future generations. Thank you. And here are my contact details and the promo video. Feel free to reach me with any questions and comments. I'm happy to meet you all in the breakout room. Thanks again.